Yeah, thanks, Shane, and thanks to Alan for really setting the scene there and really sort of defining some of the challenges in front of us. And the next sort of 20 minutes or so are really going to be looking at where we go in terms of particularly industrial refrigeration, in terms of the engineering challenges. It's going to be a bit of a story about what we've done so far, what we're going to be, what we can do now, and then looking a little bit further in terms of what the future may hold for us. And as a company, Star is 50 years old this year. We were founded in October 1970, and throughout our life as a business, one of our big focuses has been on how do we actually reduce energy consumption for our customers? How do we give them as efficient operation as we possibly can do? And some of that we're going to be talking about this morning. But you know, just listening to Alan's talk, it does sound like a real daunting task, doesn't it? You know, we've got lots to achieve. There's not a lot of time to do it, and the longer we take in terms of getting there means that we're just putting more and more energy into the atmosphere. It's warming up, and you know, the task becomes harder and harder. The shot here is actually taken from the summer this year. I actually managed to get away for a little while into the Lake District, and here's one of my daunting tasks. I was walking, should I say, in the Lake District, and 2 hours in, several thousand feet up in the air, and looking at the vista in front of me, thinking, "Oh, this is beautiful." On our way down shortly, only to be told we were heading to the mountain in the left there, which was some way away, and quite a daunting task. And you know, the daunting task that we have in front of us, we think, well, how are we going to get there? What are we going to do? And I was, in terms of some inspiration, I was actually looking for some quotes, and I just thought this from Nelson Mandela was a good one. It's always seems impossible until it is done. And I think one of these things, with what we've got in front of us, how do we get there? How are we going to achieve this? But I firmly believe that 20, 30 years down the line, we can be looking back and saying, you know what, it did seem impossible in 2020, but look at the great strides that we've made, look at the great changes that we've made. And there are some positive signs, and we'll come on to those shortly. But, you know, going back to what Alan was saying, many people will think the answer is, yeah, let's just use renewables. Renewable is the answer to everything. That will give us what we need. But there will be such a great clamour for renewables, particularly around industrial refrigeration. Most refrigeration systems providing cooling to temperature-controlled warehouses are electrically driven. And actually, a fundamental step that we really do need to focus on, and the first step that we need to focus on, is actually reducing the demand for the energy. We really need to take a long, hard look and saying, well, why do we need all this energy to run the cooling systems within our refrigeration systems that we do at this moment in time? Is it really necessary, and can we reduce it? And at that point, we should really be moving on to this, then the next question about efficiency. How efficient is the system that I'm operating? I think what we'll look and what we'll see in the next sort of few slides is that we focus very much on section 2, but taking a step back and looking at section 1 is where we will really make the big benefits. You know, refrigeration has a defined efficiency. There's only so efficient you can get a system. There's things you can tweak, there's things you can play around with, but actually cutting the demand for the energy in the first place is where you can make some real big impact, and will get us where we want to achieve. And then finally, once we've got the minimum amount of energy that's required, we're doing it as efficiently as possible, then switching over to that renewable energy source means that we won't be pulling as much demand as we are at this moment in time. So three things there. I'm really going to be focusing on 1 and 2. So where have we got so far? Well, an encouraging start, if we look at the recently published document from the Cold Chain Federation on climate change agreement performance, you know, from 2013 onwards. As an industry, you've exceeded your targets, you know, which is a really good and positive step. But how have we got there? Well, just some observations of things that I've certainly seen and have come back to me through working with operators in the industry. The first of which is that there has been a real change in the focus. There's been a greater focus on total cost of ownership of particularly cooling systems. You know, on sites, they're the biggest energy consumer, and apart from transport, which we've already covered with Alan, these are a major carbon emitter for any business in terms of the energy that they consume. And there's been a real greater focus in terms of how can we get that energy cost down, because in the life of a refrigeration system, more than 60% is down to energy. Historically, there'd often been a focus on capital cost, and that still remains important. But actually, investment at the capital stage can save significant amounts of energy in the future in terms of operating efficiency, not just at peak demand, but also throughout the year. It can also help in terms of reliability as well, and providing better maintenance costs. And one thing that is very clear as well is that operators are much more focused on what their running costs are. They've got a better handle on what those on the energy consumption for their site is. A bit I'll come on to a bit later on is do you know whether that's good, bad, or indifferent? And a further step that people have taken is moving away from high GWP gases. I know Alan mentioned that previously, and moving towards gases like ammonia, which have no effect in terms of global warming if they do pass into the atmosphere. From a refrigeration industry point of view, manufacturers of equipment and suppliers of systems have been really focusing hard in terms of improving efficiency of plants, both in terms of new equipment, but also retrofitting energy-saving devices onto existing equipment. Things like compressors, which are the real heart of any refrigeration system and typically consume 70 to 80% of the energy, have been a real focal point. Selecting the right type of compressor based upon the application, the temperature, the size, and load profile within a store. Chill store load profiles differ quite considerably to cold stores, for example, based upon ambient temperature. Really focusing on that, picking the right equipment. Fitting variable speed drives is very good in terms of part load efficiency, because refrigeration very rarely runs at its design capacity. It often runs at much lower capacities and in lower ambient temperatures. And then also looking at things like EC fans on evaporators and condensers. That's helped reduce energy consumption there, and they typically account for about 20% of the overall system operating cost in terms of energy drawn. And then the amount of energy that's consumed throughout the year, how we can take benefits in the seasonal changes in temperature, because as the ambient temperature reduces, we should be able to take benefit of that and actually reduce the consumption of plant. So we've looked at how we can better optimize that, and by fitting various pieces of equipment, we've achieved certain improvements. Then looking at things like controls. Controls have become more sophisticated through the development of PLC systems. They enable you to basically take the best advantage of all those components that you've fitted and bring them all in together to an overall system improvement. And then moving on from that, they've also further developments mean that you can actually monitor real-time performance, and actually it can actually alarm and alert to say we are moving away from what is good for in terms of efficiency, and you need to come and do a service visit or improve various aspects of the plant operation. In addition to that, and one of the things that has also been happening is benchmarking in terms of minimum efficiency for equipment. So refrigeration equipment for cold storage, for chillers and the likes now have a minimum efficiency level set as part of the eco design directive from Europe, and that's helping to ensure that we are moving minimum efficiencies of which people can bring equipment to the market. But in all of these cases, further improvements are necessary and can be made. So just showing that graphically, if you look at a typical system, a traditional type of system as being your 100% energy consumption, moving to efficient equipment, we can get significant benefit from things like variable speed drives on pumps, fans, compressors. Typically in this example for an installation that we looked at, about 19%. But the real boost in efficiency comes from actually tying that all together and making sure that whatever is controlling the starting and stopping and speeding up and slowing down of all these fans is operating efficiently. And then more importantly, as the plant goes through its operating life, is monitoring to make sure that it retains its efficiency. Because it's one thing to have a plant that's efficient on day one of commissioning, but 5 years later, it still needs to be there. Otherwise, this creep in energy consumption, which can be small year on year, but over many years can be quite significant. Further improvements, there's been a lot of changing in terms of store operating temperatures, particularly at lower temperature. Traditionally, -25 or -28 might have been used for frozen storage. But for every degree we increase the temperature of those chambers, we can get a 2 to 3% improvement in energy consumption. And so therefore a move towards more of a -20 type figure has been a popular move, saving 10 to 15% on energy consumption. That has to be done quite carefully, particularly when you look at it in relation to things like demand response, which is very popular within the industry as well. By raising the store temperature, you reduce the buffer, the temperature buffer that is there Should anything happen to refrigeration equipment? Should there be a power shortage? Or should you be off due to demand response? And it is a careful trade-off with those to make sure that you've got sufficient equipment and that you don't compromise product temperature when doing this. But we've seen many operators move away from the more traditional temperatures, particularly at frozen conditions, to a higher temperature to improve performance. And then the other thing we've seen is around the operation of the facility as well, a greater focus on particularly things like doors. The refrigeration plant only really runs to extract the heat that has gone into a particular chamber or building. And by far on warehousing, the biggest sort of contributor to heat going into the building is through docks. So here's a couple of photographs of examples of poor door control, ill-fitting lorries onto loading docks, leaving large gaps, lack of maintenance on doors. The diagram on the right is somebody propping a door open because it was broken. They didn't want to close it because then they couldn't get it open, so they propped it open. All of the time, energy is pouring into that building, not to mention the health and safety issues associated with water coming in through the door as well. And just putting the stark facts there, for every meter cubed of air ingressing into a facility per second, over a year, that's consuming something like 100,000 kilowatt hours for a chill store, and for frozen about 140,000 kilowatt hours of energy. So we've seen much more focus on better operation, upon door control, and trying to avoid this infiltration. But it's an area we could really work on in terms of the future as well. So lots of good things that have been happening, but actually when you look at the report and the recent document issued by the cold chain, what you'll notice is that whilst around 55% of all those measured exceeded targets, there were 45 that didn't exceed the CCA targets. That's a great opportunity for those 45% that didn't, because we need to bring them along on the journey. We need to turn them from red to green. But what we also need to do is reduce the energy consumption of all those that did exceed, and we need to continue to push and improve from that perspective. The good news is that there is a real opportunity to take control of this moving forward. Alan already mentioned about this whole idea of monitoring what you're doing and assessing what can happen. And that really starts with benchmarking. And that's one thing I would really recommend that operators do. Many do benchmarking within their own business, but we heard from the previous presentation, actually, collaboration is a key part of all of this as well. So benchmarking as an industry would be a good starting point. And quite a lot of work has been done on this. There was a really good report written 4 or 5 years ago, which looked at benchmarking stores across the whole of Europe. And we'll come on to that a little bit in the next couple of slides. But once you do that, you can assess where you are. You know what the size of the task is ahead. Also, commercially, what the size of the prize is as well, because reducing energy consumption, reducing the amount of carbon emissions through the electricity means that you can actually save on running costs as well. From there, you can then start to implement a plan moving forward. And as was previously mentioned, this is an iterative process. It's a case of continuous optimization. Look at how we're performing, look at where we're heading in terms of our journey, and carrying out further improvements, and then driving down carbon emissions. And with that as well, what we tend to find is we get increased reliability. So it's a real win-win. It's really simple to do. Here's just an example of a simple calculator that we've developed with my own business. And from that point of view, it needs basic information. What's the volume of the store that you're operating? What's your annual energy consumption? Both of which you'll know because of things like the climate change agreement information. By inputting your energy costs, you can actually determine what the financial benefit would be for improving efficiency. And then a rough estimate of what the percentage consumption of the refrigeration compared to the overall site is will get you a better feel for your performance as well. But from that, what you can then do is start to benchmark. So the graph here shows some European statistics for temperature controlled warehousing based upon volume on the bottom axis there, and then specific energy consumption up on the left hand side, which is the amount of kilowatt hours per meter cubed of volume per year. And by inputting that relatively straightforward, simple information, you can compare that for the blue line at the top is the average for European chill facilities, green is for frozen facilities across Europe, and grey is mixed. What is noticeable there actually is the European performance is actually higher than the yellow line, which is actually UK best practice from 1994. And one would have expected that we've improved somewhat since 1994, but I'll come on to that later. But yeah, benchmarking on there, how well am I doing? And actually, should we be setting some more strict and challenging targets as we move into the future? From that benchmarking, then what you can also see is, well, how many tons of carbon CO2 emissions could I potentially save if I get towards a future best practice target? And you can start to measure that. You can start to measure your performance against it. You can start to implement changes in the way that you're doing things and seeing whether you're heading in the right direction towards that. And at the same time, you can also get a feel for what that would save in terms of operating costs per year, because some of that then can be ploughed back into further investment. What we also have the opportunity now as well with the technology that is in the marketplace at the moment is to really take control of day-to-day performance of this big energy consumer on any site. As the owners and the operators, you can get that information in real time. You can see when performance starts to slip, and you can actually take control of that and deal with it straight away. Most modern refrigeration systems have the necessary telemetry and information. It's just not extracted and turned to good use. But with modern software, we can perform calculations to determine actual plant performance and compare this to what it should be doing based upon the way that the plant was designed, looking what that gap is, and then saying, well, from that gap, what are the steps that need to be taken to get me back to an optimum position in terms of performance, to get my carbon emissions down from my refrigeration system, and what's the benefit going to be if I implement these? So yeah, taking back control of all of that, finding out, is it because of underperforming equipment? Do set points need to be changed on it? That information can all be extracted, taken away, and this is all done. It can all be done in the cloud, away from site. Reports issued on a regular basis, and therefore you're taking control of what is actually happening on the facility, day by day, week by week, month by month. It's basically moving the refrigeration plant from that room at the back of the facility that's quite noisy, that nobody ever goes in, and bringing it to the forefront and putting it in the vision of those that are actually operating the store. It can also then, through the savings that are projected and through an understanding of load profile, really provide useful information to drive your business moving forward. So that's where we've gone. That's what we've got available to us at the moment. So it's really using that big data to drive the business based upon what we have at the moment. But what does the future hold for us? Well, we're talking about moving from this 2020 position. We've already seen the graphs in terms of how challenging that's going to be. And getting down to net zero, I said at the very beginning, is really about looking about what the demand for energy is, driving that down. And that, going back to one of the earlier points as well, is a collaboration. It will involve, in the future, looking at the building design, looking at innovation in there to reduce the amount of energy that is going to be needed for cooling, to reduce the demand for cooling requirements within the facilities. It's going to need to look at how the store is operated. If the operation is bringing in large amounts of warm air, which is creating a huge energy demand within the facility, how can you reduce that down? What are the steps that can be taken? How can that be done better? And at the same time, what are the engineering innovations that are being developed? What is the best in class equipment that I can be using to drive down my energy consumption? And that is a collaboration. It's bringing together the designers, the architects, the construction companies. It's bringing together the operators in terms of innovation on that side, and the engineering businesses to actually support that. And then it's really setting those benchmarks. The orange line at the bottom of this graph was from a paper produced last year, looking at best practice potential in 2019. And what you'll notice is that since 1994 to 2019, based upon equipment that is currently being installed and measured in terms of performance, there's a belief there that we can set a target that is reducing energy consumption by roughly 2/3. And actually, that as we get to bigger stores, we can reduce that energy consumption even further against the against the 1994 practice, and even greater when you look at it against some of the European average figures that where we are now. So it looks a really daunting target. The Positive news is that the data taken from existing facilities is suggesting this is possible, and through that innovation that we spoke about on the previous slide, there's no reason why we couldn't actually get there. It's all about reducing that demand, then making it as efficient as possible, and making sure that that's implemented, and then moving to that renewable source. But then we have to start to look further afield, because we've got this warehouse, we're keeping it nice and cold, but as an industry, we basically take heat out of a warehouse, we put some more energy into it, and then we chuck it out into the atmosphere. And I know we talked about this earlier in the year in terms of combining heating and cooling, but the cooling industry is one part of the equation, but a much bigger carbon user within this country is heating. And that's heating of businesses, it's heating of homes, it's heating of office blocks, it's heating of towns and cities, etc. At the minute, as an industry, we're chucking lots of heat away, which actually, if we could actually capture that heat and boost it, and put a fraction of the amount of energy into it and carbon into it than we would do typically using boilers or gas, we can actually take that heat, extract it, and use it elsewhere to provide heating into homes, to provide heating into businesses. And all of a sudden, we're not just actually a consumer of a carbon, but we're actually be able to save carbon elsewhere in the bigger picture, because we're actually going to be donating all this free energy that we would have previously thrown away in the past. That's going to need quite big infrastructural changes. We don't have district heating as a standard in this country, but could we be feeding our energy into a ring main that then goes off to get taken somewhere else to be put through things like heat pumps to generate heating for houses? That way we're decarbonising our heating, but we as an industry are then contributing to that. So just a blue sky thinking further forward, but actually your business may no longer be a cooling business, but it might be providing energy for heating as well in the future. So to summarize, so far we're making good progress. We've seen a lot of improvement, particularly focused around the efficiency aspect of equipment, certainly in refrigeration. And we've definitely seen a change in people's focus in terms of looking at what the life cycle costs are for equipment. Right now, we've got this opportunity to really capture the big data that is available to us, that is being produced all the time, particularly by our refrigeration systems. We can capture that. We can use that to first benchmark where we are, set our strategy, and then look to measure and optimize on an ongoing basis. And then in the future, it really is about setting some really challenging targets to get us to where we want to be in terms of this net zero. That's going to be a collaboration of bringing people together in terms of building design, operation, and engineering, and using innovation from all of those. There is this change to renewable energy to decarbonize our electricity, but also to think outside of our own warehousing. How can we take away our waste, recycle that waste, and give it to others who may find it really useful? So lots covered in there, and I really thank you for the opportunity. But we're happy to answer questions afterwards, and if anybody wants to get in touch with me, there are my contact details. But hand it back to you, Shane.
Thank you, Rob. Thanks very much. And that's a really good summary of sort of really dovetails nicely with what Alan was saying about the sort of big picture, how networks fit together in terms of freight transport, talking about the buildings themselves. I guess my sort of immediate thought is what effectively you're presenting is the sort of the medium term, the relatively long term view of net zero in terms of buildings is marginal gain. It's a constant improvement on what we do currently, rather than game-changing technology. What you're not saying is, in 10 years' time, we'll be doing refrigeration fundamentally differently to how we do it today. Is that right?
I think so. I mean, there are some big fundamental steps that we can take pretty quickly, but as Alan pointed out, there's investments involved all the way along here, and for businesses to do this, they need to invest continuously. I think the benchmarking is the first step. The benchmarking will tell you, are there some quick wins, and what are those steps can be. What we can see is that, and what we've seen through our own benchmarking that we've done with various people within the cold chain, is that they can be varying from anywhere from being on the European line to being half the European line. And it's then saying, well, why is that facility different to another one? And what is it we can implement, and what can we do? And you can get some very quick wins through that. But it's then really about maintaining that. Because whilst we're measuring energy at this moment in time, we don't know whether that's good, bad, or indifferent. And I think we really do need to get a grasp of that. and then start to work towards improvement. And a lot of that investment will be when equipment comes to the end of its working life. It might be investment in new facilities as we close down older facilities. You know, a lot of the infrastructure here is 20, 30, some of it 40 years plus old. And there's only so much you can get with that. You know, the buildings are tired. They were built in a period when energy wasn't the focus at that point. And there's a lot of innovation in the way that the logistics is being done, which is actually reducing the density of cooling for a facility as well. I think move to automation being an example.